Welcome pre-calc students to the homework help video, page 396, numbers 23 through 34. I hope this help video will allow you to find your mistakes if you're struggling with any of the problems on this assignment. Okay, the directions say, I believe, something to the effect of expand these. Let's just find the directions here. Express in terms of sums and differences of logarithms. So here we go. I've got an argument here in which I've got a bunch of multiplication going on. I have 6, put a dot here, 6 times, and times. So whenever you have an argument with multiplication, you can write the first part of the product plus. Notice if your base here is A, we're going to use base A throughout the entire assignment of x and then plus log base A of y to the 5th plus log base A of z to the 4th. Now, the only thing left that I can see to do is we're going to cross off this 5 and put that 5 right here to the left of the logarithm, and we're going to cross off this 4 here and we're going to put it right here. Now let me check the back of the book and make sure that I'm right. I always want to check my answers, but I don't think there's any mistakes there at all. Give me about 10 seconds. And there we go. I'll keep this page open from now on. 6x5. Yes, we are good. Moving on to number 24. Okay, it's the exact same type of problem again. We have an argument here in which everything is being multiplied. So we are going to write log base A of x to the 3rd power. And then because these are products, we're going to put a plus sign and then plus log base A of y squared, and then plus log base A of z. And now really there's nothing else to do except to move your exponents to the left of the logarithm, which is what we're doing now. And that's not what we're doing. Here we go. How's that? And then we'll just shrink it back down. There we go. There we go. And we are finished, okay? You know you're done, students, because there's just an x here. There's no product or quotient. There's just a y here. There's no product or quotient. And there's just a z here. There's no product or quotient. There's no exponent here, here, or here. So you're totally finished, okay? And let me glance at the answer book here and make sure that we are right. Yes, we are, and we're moving on. Number 25. Now notice here we have a quotient, a division bar. So we're going to start off by writing this as 2 separate logarithms with a subtraction sign. So log base b, and then we put the numerator, p squared, q to the 5th, and then put a minus sign because we have a dividing argument. And then we're going to put log base b of m to the 4th b to the 9th. Now, notice these two are being multiplied, so I'm going to write this logarithm here as 2 separate logarithms. So log base b of p squared, and then plus log base b of q to the 5th. And now be careful here. When I put a minus sign, I notice I'm going to split this log up, so I'm going to go ahead and put parentheses because this minus sign right here that I brought down to here is going to go to everything inside of that parentheses. So I'm going to put log base b of m to the 4th plus, now why a plus sign? Because the m and the b are multiplying, so plus log base b of b to the 9th. Okay, not too bad. Now let's go ahead and move our 2 and our 5 here. Let's move our 2 to right here. Let's move our 5 to right here, and let's get the whole thing, of course. There we go. And now this negative sign would get multiplied through. I guess if we wanted to, we could move the 4 first. We could do that. So let's take this 4 and let's put it, I always struggle with that, don't I? Let's pick up this 9 and we're going to put the 9 right here. And let's take this 4 and we're going to move it right here. Okay, there we go. Now this negative sign would get multiplied times the positive 4 and times the positive 9. So when that happens, your 4 becomes negative, and then also your 9 would become negative. And so there we go. Now it looks like you're finished. I mean, there's really nothing you can do with a P and a Q and an M and a B. But remember, I've taught you to see if you can't simplify the logarithm further. And you have to look for things like base B of B. Let me get a drink of water here. And notice that's what I have right here. I have base B of B, log base B of B. And so I can probably simplify that. Now I'm going to leave the negative 9 right where it is, okay? But I'm going to pull this down here. I think I can simplify that very quickly, set it equal to x, and now write that exponentially, and you would have B equals B to the x. And look at that. We all know there's a 1 there. And so B to the 1 equals B to the x. X equals 1. So if x equals 1, I really have a 1 here. So b base b log base b of 1 equals 1. So really, where I had this logarithm right here, I can now just put a 1. So really, I now have negative 9 times 1, which is just negative 9. And this, now I'm going to check the answer key in a second, but that should be your final answer. And yes, it is. Okay, moving on to number 26. Same problem again, students. We have a division line here. So I'm going to start off with writing a difference, or in other words, two logarithms being subtracted. My numerator, x squared y, goes here, and then minus log base b of b cubed. Okay? Now, we really can't split this logarithm. I mean, if you want to move the 3, that's fine. So negative 3 and then log base b of b. But I can split this logarithm up here into two logarithms. I can, because they're multiplying x squared times y. I have an argument in which the variables are multiplying. So because of that, I'm going to write log base b of x squared plus, because I have a product here, log base b of y. And then of course we should know by now I will pick this 2 up and I will put it out front. It's a small little 2, but I think we get the idea. Maybe we can make it a little bigger. Now it looks like we're finished. We have just an x here, just a y, and just a b. But remember, if your base is b, which it is, you're looking for something like base b of b, and we have that right here. We have log base b of b. So, I mean, again, once this is going to equal 1. It's just like the last problem that we did. I'm going to go back a page. That's not what I wanted to do. There we go. I mean, look, students, right here, it's the same thing all over again. We had log base b of b equals x, and then you write it exponentially, x equals 1. So log base b of b equals 1. Now we're going to learn a faster way to do this later on this week. I think tomorrow actually, a shortcut. But for right now, log base b of b does equal 1. So this is going to equal 1. So I really have negative 3 times 1, and negative 3 times 1 is just negative 3. Let me check the answer key and make sure that we're right, but that looks pretty good. Yes, we are fine. Moving on to number 27. Well, again, it's pretty redundant, but here we go. Same thing. I have a quotient here, so I'm going to write natural log of 2 minus the natural log of 3x cubed y. Now, natural log of 2, I have just a 2 here. There really isn't much I can do with that, so I'm going to write natural log of 2. I'm going to bring down my minus sign, or my negative. Then I'm going to put a pretty big parentheses, because look at your argument. You have 3 times x cubed times y. So I can split that product up into natural log of 3 plus the natural log of x cubed plus the natural log of y. And then you should be able to see by now, you would grab this 3 and put it right here. And then students, the only thing left to do is to take this negative sign. And by the way, I'm not sure why I put this 2 way up high like this. It should be the natural log of 2. It should be right here. There we go. The only thing left to do is to take this negative sign and multiply it through. So if I took a negative times, there's a positive sign here, a positive 3 here, a positive sign here, you're just going to get negative signs. So I'm going to pull this out of the way. So you would have a negative natural log of 3, a negative 3 natural log of x, and a negative natural log of y. Okay, and there we go. That's it. Take your negative sign, multiply through. Let me check the answer key real quick. Everything looks good, and that is the correct answer. Moving on to 28. Well, pretty redundant, but here we go. First of all, we have a quotient, so I'm going to write log. There's no base, so we know it's understood to be 10. Now, you don't need to write the 10. That's the nice thing about a common log. Okay, it's a little faster, but it is understood to be 10. Log of common log of 5a minus the common log of 4b squared. Now, I have 5 times a here, so I'm going to write this logarithm here as two different logarithms. So log of 5 plus the common log of a, and then minus, then be sure and put parentheses because the negative sign goes to this entire log. So we're going to have inside the parentheses the common log of 4 plus the common log of b squared. Okay, now we're going to pick up this 2. Obviously we're going to put it right here. I see no other exponents that I can do that with. I do see a negative sign here I can multiply through. So I'm going to pull these parentheses out of the way. And if I took a negative sign times this logarithm, I'd get a negative. And if I could take a negative times this logarithm, I would also get a negative. And I don't see, my base is 10, and I'm not seeing any base 10s with tens or hundreds or thousands or anything like that. So I don't see any more simplifying I can do. And I'm checking the answer key now, and we are good. Number 29. Now I want to encourage you, the first thing you need to do is to rewrite your problem like this. R to the 3rd power t, and then put parentheses around that whole thing is to the 1/2 power. Because look, students, this whole r cubed t is under the square root. So if it's under the square root, then we know this entire thing is to the 1/2 power. Now your r has a power of 3, your t has a power of 1. And so let's multiply the 1/2 through, which you're allowed to do when you're raising a 1-termer powers to powers. So I would have the logarithm of r to the 3/2 power, 3 times 1/2, times t to the 1/2 power, 1 times 1/2. Now that's going to be split up into 2 logarithms. Why? Because we have r times r. So I'm going to write the logarithm, the common log of r to the 3/2 power plus the common log of t to the 1/2 power. And then hopefully by now we're getting the hang of this. Your exponents should be written to the left of the logarithm. And I'm not seeing any simplifying we can do. Remember, your base is a 10. You don't have to write that, but I'm just putting it so you can see it. If I had like a 10 here and a 100 here, then I would be a little concerned about that, because I know 100 could be rewritten as 10 squared. Then you've got base 10 or something like that. But I'm not seeing anything like that. All of my logarithms here are letters. My arguments, all of my arguments are variables, letters, and so there's really nothing more I can do. I'll check the answer key to make sure, but yes, that is the correct answer. Okay, moving on to number 30. Pretty much a very similar problem, only now instead of a square root we have a cubed root. Excuse me. So I'm going to write the natural log of 5x to the 5th all of that to the 1/3 power. Now don't forget the power or the exponent of the 5 is 1. Take your 1/3 and multiply it through. And now you have the natural log of 5 to the 1/3 power x to the 5/3 power. And now notice that you have a 5 times an x, so we're going to write that as two separate logarithms. So the natural log of 5 to the 1/3 power plus the natural log of x to the 5/3 power. Okay, now the only thing left to do is to obviously move your exponents or your powers to the left of the logarithm, which we have done. And there we go. We're looking pretty good. If you want to bring that plus sign over a little, you can. And that's it. I mean, don't forget your base is e, and your base is e. I'm not seeing any base e of an e or base e of an e. I'm seeing base e of 5 and base e of x, but that's all that I'm seeing. So let me check the answer key to make sure, but I'm pretty sure that's all we can do. Yep, that is the correct answer. Okay, moving on to number 31. Okay, going pretty fast here. I'm going to write log. Actually, I'm going to go ahead and just put parentheses up here to save time. We have a square root, so I'm going to take this entire thing to the 1/2 power. So I've gotten rid of the square root, and now I'm taking this entire thing to the 1/2 power. Now I would have, if you take your 1/2 and multiply it through, 6 times 1/2 is 3. 5 times 1/2 is 5 halves. 8 times 1/2 is a 4. There we go. Oh, I forgot my base a. There. Now, what I've taught you to do is when you have a quotient in your argument, start with the quotient first. So I'm going to write log base a of x cubed and then minus log base a of p to the 5/2 power q to the 4th power. There we go. Now, as I look over here at this logarithm right here, I'm going to erase this to get a little bit of room to work. But when I look at this logarithm here, I just have an x. So I know I can grab this 3 and just pull it right over here and maybe make it just a little bigger and then put it right here. And that's fine. In fact, I'm going to move this whole thing over to get a little more space. But if you'll look at the logarithm here to the right, I have a p times a q. So we're going to have to split this up into two logarithms. So minus, and then parentheses, log base a of p to the 5/2 power plus log base a of q to the 4th power. There we go. Now I'm going to go ahead and just bring this down to save a little bit of time. So this is still right here. And the only thing really you could do to save time is we could slide this over a little. We could put our 5/2 as we know. It should be to the left of the logarithm. And then we know this 4 right here should be right in here. And that's a pretty ugly 4, so we're just going to get rid of it. And we'll put a 4 right here. There we go. Now we take this negative sign right here and we multiply it through times both logarithms, okay? And if we do that correctly, a negative times a 5/2 would be a negative 5/2, and a negative times 4 would be a negative 4, okay? And so I'm not seeing a lot more I can do. I've got base a, there's no a here, there's no a here, no a here. That's the best I can do, I'm pretty sure. Let me check the answer key and make sure. Yep, we're looking just fine. Moving on to number 32. Now here I have a cubed root. So I'm going to save some time and I'm going to go ahead and just put parentheses right here and parentheses right here and go ahead and put a 1/3 power right here. Now multiply your 1/3 through and you will have log base c of, well, 1/3 times 3 is 1, so y to the 1. 2 times 1/3 is 2/3, so z to the 2/3. And then 1/3 times 4 would be x to the 4/3. Okay? And now start with your numerator first, or excuse me, start with your quotient first. So our numerator, we're going to have log logarithm of c, and then your numerator, so y to the 1, z to the 2/3, and then minus the logarithm base c of x to the 4/3 power. Okay? And then notice, if you want to very quickly, you can grab the 4/3 and you can put that to the left of the logarithm. That's totally fine to do. And then notice over here to the left we have a y times a z, so I'm going to split this logarithm here up into two logarithms. I'm going to write log base c of y plus log base c of z to the 2/3. And then of course you're welcome to bring down this last logarithm. In fact, you should bring that down, so we'll bring it down and put it right here. Now the only thing left to do is, you can see you do have a 2/3 right here, and so I'm going to go ahead and grab that and drag that to the left. And I don't see anything else we can do. I have a c to a y, base c of y, base c of z, base c of x. I don't see any simplifying I can do. Let me glance very quickly at the answer key, but that's looking pretty strong for an answer. Yes, it is. Okay, number 33. Well, I'm going to go ahead and cross off this 4. I'm going to go really fast now, students. I think we're really getting the hang of this. I'm going to put 1/4 here. So I'm going to multiply my 1/4 through. I would have this right here. Logarithm base a of m squared into the third, 1/4 times 8, 1/4 times 12, and then a to the 3/4 and b to the 5/4. Okay? Now I can rewrite this logarithm as two separate logarithms. So I'm going to write log base a of m squared n cubed, that's my numerator, minus logarithm of a, and then a to the 3/4, b to the 5/4. There we go. And now look at this. Let me get a drink here real quick. Now we've done a lot of these. We've done 10. These last two, 33 and 34, are numbers 11 and 12. I think it's our last two, I believe. Yes. And so I'm going to skip some steps here. I think you're ready for that. Notice over here I have m times n. So instead of writing log base a of m squared, I'm going to put an m. Instead of putting a squared here, I'm going to go and put a 2 out front. And then because it's m times n, I'm going to put a plus sign and then leave a little space. Instead of writing log base a of n to the third power, instead of putting the 3 right here, I'm going to go ahead and put the 3 right here. Okay, and then minus. Now don't forget we're going to put a parentheses. Okay, and then I would have log base a of a. Now instead of putting a 3/4 right here for the numerator, I'm going to go ahead and move that to the left of the logarithm, and then a times b. They are multiplying, so I'll put a plus sign, and then I'm going to write log base a of b, and instead of putting a 5/4 power, I'm going to go ahead and move that now and put 5/4 here. And then when you take this negative sign and multiply it through, it should be pretty obvious what you get. A negative times 3/4 will be a negative 3/4, and a negative times 5/4 will be a negative 5/4. Now, I do have one more thing we need to do, and hopefully you're catching this on your own. I've got a base a of m, a base a of n, a base a of b. Those are all fine, but look, a base a of a. So I've got I can simplify that. So I'm going to grab this log base a of a, pull it down, and I'm going to say, okay, I'm going to set it equal to x. I'm going to write it exponentially, so I would get a equals a to the x. There's a 1 here, so x has to equal 1. So where this x is really a 1. So log base a of a equals 1. So 3/4 times 1, or negative 3/4 times 1. And of course, negative 3/4 times 1 is just negative 3/4. And so I'm going to go ahead and slide this over. Probably in most books, let me glance in the back of the book here, they did leave their 3/4 right in the middle. I thought they might want to move the negative 3/4 to the end over here, but it doesn't matter either way. I would give you credit. So that is the correct answer, I believe. Let me check everything. That is it. Okay, so one more to go and we're doing really well. Okay. Okay, notice we have a square root here, so I'm going to very quickly put a parenthesis, and instead of a square root, I'm going to put a 1/2, and now let's multiply the 1/2 through. So I would have log base A of 6 times 1/2 is 3, 8 times 1/2 is 4, 2 times 1/2 would be 1, and then 5 times 1/2 would be 5 to the 5/2. Now, or b to the 5/2. Now, students, listen. Come on, students, think this through. Anytime you can simplify your argument, do it. I mean, why not do it? Look what you have here. You have a cubed over a to the 1. Now, remember what I've taught you. You take the numerator minus the denominator, and you write the base one time in the top. So if you have like bases being divided, you write, I'm going to go and do my work down here. You write the a once in the top, and you take 3 minus 1, and you get 2. So a to the third over a to the 1 is a squared. Now, you can use a calculator if you're not good with fractions. Notice I have a b over b, so I write the like base once in the numerator, and 4 minus 5 over 2 would be 1.5, or 3 over 2. And you can use a calculator if you need to. Type in 4 minus 5/2, you'll get 3 over 2. So now there's not even a fraction left. It's just the whole fraction reduced down to this right here. So that's going to save me a lot of work. Okay, so there's my argument. Now I have an argument in which the a is multiplying the b, so I'm going to write log base a of a squared. But instead of putting that squared right there, I'm just going to go ahead and put it out front here, and then put a plus sign because the a and the b are multiplying. Logarithm base a of b to the 3/2. Now instead of putting that 3/2 right there, I'm going to go ahead and move that out front. Now we're almost done. It looks like we're doing really well, but look, you've got a base a, log base a of a. Well, this whole expression right here, I'm going to highlight it in red. That whole expression right there equals 1. We just looked at that in the last problem right over here. That's the wrong button to push. I'm not sure, did I erase? I think I erased it. We had log base a of a, and it equals 1. And so this whole expression right here really equals 1. So I really have 2 times 1, which is just 2. So what I really have is just 2 plus 3/2 logarithm base a of b. And I did just check that, and that is correct. So there we go. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.